Welcome to the program. I'm Jeff Schechtman. In trying to understand what makes us tick, people still debate the old nature versus nurture argument. Yet modern science, medicine, psychology, and biology tell us that it's far more complex. In fact, it's a little like a variation of the uncertainty principle in physics. The very act of trying to understand our behaviors or the behavior of others tells us more about the observer and sometimes the way in which the observer even influences that behavior. This complexity is what we're going to talk about today with my guest, Robert Sapolsky. Robert Sapolsky is the author of several works of nonfiction, including a primate's memoir, The Trouble with Testosterone and Why Zebras Don't Get Ulcers. He's a professor of biology and neurology at Stanford University and a recipient of a MacArthur Foundation Genius Grant. It is my pleasure to welcome Robert Sapolsky back to this program to talk about his newest work, Behave, the biology of humans at our best and worst. Robert, thanks so much for joining us.
Well, thanks for inviting me.
It's great to have you here. To what extent are we still learning all of this? Is science and biology today still giving us more and more information about what makes us tick and the way in which all these different areas come together in the way we act and the way we behave?
To a ridiculous extent. And when you consider the biology of behavior and what our brain chemistry and our hormones and our genes and our early experience and our fetal environment and culture and ecology and evolution, when you throw all of those in together, what you realize is a large part of the last century in terms of these scientific advances has been spent with people saying, oh, I had no idea biology had to do with something like that when I behaved this way, or that I had no idea hormones affected that, or brain chemistry, or whatever. When you look at specific areas, the frequency with which we have been saying, oh, I had no idea that had something to do with it, the number of things, the amount that we have learned about, half of that we have learned in the last 20 years. Like 40% of it we've learned in the last decade. The rate at which we are getting new insights into what biology has to do with behavior is really extraordinary.
And part of it is our nature, from a scientific perspective, I suppose, to want to try and figure this out, to be able to take brain chemistry and hormones and DNA and psychology and environment and genetics and be able to put all this stuff together and write some kind of algorithm for it and have an answer at the other end.
Yep, because in lots of ways, the most fundamental human question we ever ask about sociality is somebody does something or other, and we say, why did that person do that? It was like some wonderful, compassionate thing. It was some appalling, violent thing. It was something somewhere in between. And like a basic drive we have at that point, which drives a huge percentage of gossip and social judgment and everything else, is trying to answer the question, why did that person do that? And what we're discovering is biology is sort of the underpinning of virtually everything we do.
And what it tells us, it seems, is that there's a kind of irrationality that is inherent in human behavior, and irrationality in terms of trying to answer that why question.
Well, irrational in the sense of we have to accept that insofar as we're biological creatures, we humans, we're apes, we're primates, we're mammals, our basic building blocks are identical in all these other species out there. Where some of the irrationality has to come in is recognizing how much our behavior is being influenced by biological factors that we haven't even a clue is playing a role. Who would think that, for example, the level of stress hormones you were exposed to as a fetus from your mother's circulation has a major influence on 60 years later some aspects of your metabolism or your risk of certain psychiatric disorders? Or who would think that the number of hours that have passed since you've had a meal has something to do with how you judge whether or not somebody should be found guilty of an act or not, and everything in between. There's just an awful lot of biological stuff just rumbling beneath the surface, having tons to do with what we view as our everyday choices about life, where they're biologically based instead.
An example of that is what we're finding out in terms of the impact of childhood trauma, childhood adversity, and the degree to which that affects our DNA and affects things, as you say, 60 years later.
Absolutely. This very trendy field that you allude to, epigenetics, the fact that experience rarely changes our DNA in the sense of changing the sequence of our DNA, but what it changes dramatically is the regulation of our genes. And some of these effects are lifelong. And what you see is have an adverse childhood, a childhood filled with abuse of any sort, filled with observing abuse in others, a childhood filled with threats of violence and a home that's unstable, substance abuse, poverty, instability of all sorts, what are now termed ACEs, adverse childhood experiences. Sit there and count them up on your toes as to how many of these categories of adversity a child has had. And not only do we now understand a huge amount about how that changes the trajectory of that child's life, what their risks are of completing our high school education, what their risks are of antisocial violence, what their risks are of having a first child when they're 16, what their risks are of dying at an early age. We not only know a huge amount about the effect of that on the trajectory of somebody's life, but we even understand the biology of what changes occur in a child's brain in response to an adverse childhood, in response to a loving, safe, stable one, everything in between. That makes for a different sort of brain in adulthood and different sort of decisions.
The exciting part of that, on the other hand, is the degree to which we're finding out that some of this is reversible, and even more reversible if it's dealt with early enough.
Yep, and another terribly trendy field of what's now termed neuroplasticity, very little about the brain is set in stone. Neurons, brain cells, they grow new connections, they detach old ones, brain areas get bigger, other ones get smaller in response to experience. Amid sort of one theme of developmental behavioral biology, which is, go and foolishly pick the wrong family to get born into and have a lifetime or a childhood filled with all sorts of aspects of adversity and stress, and that sure makes for a lot less cheery of a prognosis for the rest of your life. Amid that picture of, wow, potentially lifelong consequences, what neuroplasticity teaches us is a lot more of that stuff is fixable than people ever used to think, with the caveat that you bring up. The longer you wait, the more of an uphill battle it's going to be.
Amidst all of this science, one of the things that you talk about that's so interesting, even in and of itself, is the power of symbols, that symbols have over us in shaping our behavior and how that comes to be in each of us.
Well, it's an extraordinary thing. I mean, a chimp will very happily bash in the head of another chimp if it's a male from the next valley over instead of from his own group. And we will use virtually the identical biology to, bash in somebody's head for similar grounds. But then we're willing to kill each other over ideology or theology or differing political views or economic views. We're willing to kill each other because of which soccer team we support. And what that essentially comes down to is humans are willing to kill and to die for symbols, for abstractions. And that's a really extraordinary thing. I mean, people kill each other over songs, over flags, over what food you consider to be sacred or which foods are taboo. People kill each other over symbolic, metaphorical things all the time, and that's an extraordinary bit of evolution that our brains have gone through. In other words, often our brains have a lot of trouble telling the difference between the literal and the metaphorical, and we give an enormous power to the metaphorical, to the symbolic.
Talk a little bit about what you see in the way all of this information, all of this knowledge, all of this science runs headlong into what has been our traditional and arguably antiquated ideas of trying to understand good and evil and behavior and all these things that we're touching on.
Well, this is like the totally irresistible, most interesting part of all of this, because you sit and you spend enough time learning about just how much biology has to do with our behavior, and how much of that is biology we're not aware of, we don't have a clue of. Somewhere in there, this whole quaint notion of free will starts seeming very shaky in there. And that's certainly relevant to how we judge people harshly, but it's also relevant to how we judge people lauding them. We're biological organisms, but it's got to have a major impact on how we think about some very fundamental issues out there, and you're bringing in words which, from a biological perspective, simply don't make sense. Words like good and evil. I mean, just as an example of it, part of the brain, frontal cortex, most interesting part of the brain, far and away. We've got more of it than any other species. It's most recently evolved. What does the frontal cortex do? It makes you do the harder thing when it's the right thing to do. Self-control, long-term planning, gratification, postponement, emotional regulation. And if you extensively damage somebody's frontal cortex, you will have somebody who can tell you the difference between right and wrong. They can give you fantastic advice as to the prudent things you should be doing in your life, but get them in an emotionally aroused situation, and 1 second after they tell you the prudent right from wrong thing that they're going to do, they're going to do the wrong thing every time. They're going to make an impulsive, disastrous decision. And what you see is, just as one factoid to throw into this mix here of what to make of all of this, approximately 25% of the men on death row in this country have a history of concussive head trauma to the frontal part of their brain, to their frontal cortex. And when you look at somebody with frontal damage, and you have to choose between two narratives. One is you are seeing a rotten soul that is involved in evil acts when this person has gone and done something appalling and violent. Or the alternative narrative is you're looking at a car whose brakes don't work. The latter is a lot more biologically informed. And at the end of the day, when you see a situation like that, cars whose brakes don't work, you don't let out on the street. You protect people from those cars. You fix the brakes if you can. If you can't, you put the car in a garage for the rest of the time. And you don't talk about the person, you don't talk about the car having a rotten soul at that point. And you simply accept there is a organic impairment to that car's brakes. And in a similar sort of way, you get somebody with damage to the frontal cortex, and there's a great deal of similarity there. And if you sit there and you say, oh my God, it is so dehumanizing to view us as mechanistic biological machines, that's much better than sermonizing us into having rotten souls.
And that's where the physics analogy has some sprinkling in all of this, in that it really changes our perception of how we have to look at other people and look at how they behave in the world. And that really acts on us and our own perceptions as well.
Absolutely, and in some ways, I mean, this book that I just spent 4 years sitting and writing, it's god-awful long and all of that, and its main punchline at first pass just seems to be, whoa, it's complicated. But the more fundamental punchline, exactly alluding to what you were just saying, is it's complicated, so you better be real cautious and real humble and real careful anytime you think you understand why somebody has behaved the way they have, especially if it's a behavior that you're judging harshly, because the odds are you haven't a clue what the influences are that brought that behavior about.
There's an enormous power in this idea that everything we thought we knew about these things is essentially wrong, or at least up for grabs, at the very least.
Well, all one needs to do is to get a sense of that is look back 500 years and look at another biological phenomenon. For example, 500 years ago in Europe, somebody has a seizure. Somebody has a seizure, they flail, they fling their arms about, they fall down convulsing, all of that, and the wisest, most progressive, most empathic, most cautious, most bleeding heart, liberal-minded people at the time would have had a very clear explanation for what is the cause of a seizure like that. It's demonic possession. And the medical intervention that would be needed at that time was absolutely clear as well, which is burn the person at the stake. There was a very clear explanatory model at the time, and somewhere along the way, instead, people figured out, oh, it's a disease. It's not him, it's his disease, and there was a complete transformation of that. And we are now capable of regarding someone with the lousy luck of having, say, an epileptic seizure, of instead of saying, oh, they're obviously sleeping with Satan, we're saying, oh, they've got something screwy with, their potassium channels and their hippocampus. And we've gotten a completely different explanatory model. And you look back on somebody from that time, and they have absolutely no chance of being able to have conceptualized something like that into the way we view it now. And thus, depressingly, with absolute certainty, when we sit here and we think we understand what generates our best and worst behaviors, we have the absolute certainty that some point in the future, people are going to be looking back at us appalled and saying, my God, the way they thought things worked then, and my God, the damage they did with the judgments they made. And that's kind of an alarming thought.
And that could take us another 500 years.
Yep, or hopefully not quite as long, but the process of coming to realize that there's a very different explanation for what you thought was the nature of the world. That's a slow-going process for lots of people. We were way off on that one.
Robert Sapolsky, his book is Behave, The Biology of Humans at Our Best and Worst, just out from Penguin. Robert, I thank you so much for spending time with us.
Well, thanks for having me on. This was fun.
Thank you.